Okay, so we're going to look at sets. We're going to focus on plotting Venn diagrams. So there's a lot of introductory parts, I suppose, and there's all those bits that you need to know about your sets. So it's kind of having a read through your notes there about the different relationships, the different things, what a set is, the different notation that we use, all of those elements, kind of getting familiarizing yourself with all of that, obviously in advance of plotting your Venn diagram. So we're going to start with two set Venn diagrams. And it's important that when we're drawing a Venn diagram, we start from the inside, okay, the intersection. So we start in the middle part, and you should remember the intersection is the part that is in both sets. It's this part here in the middle. So it's the part that's common to both of the sets that we're looking at. So the things that are in both of them, it helps us then to work out what's unique to each set by kind of first looking at what's common, then we can kind of take that away from the total value for each of the sets. So the few steps we're kind of following: find the intersection, find the elements in A only, so using our set difference notation here, A take away B, and same thing here, our set difference notation here as well. So B take away A, B only. We find the elements remaining in the universal set. So remember, your universal set is kind of the whole set, the background set of the question, the kind of rectangle. Then we fill the elements into the appropriate regions, and then we add up the elements and ensure the total matches with U. Okay, so you can see that the way I'm laying it out, I'm not filling anything into my Venn diagram until I get to this second last step here. So I'm sorting out what's going to go into each of my stages first. So let's look at this. So P is the set of divisors of 12, Q is the set of divisors of 9. Use this information to represent P and Q on a Venn diagram. Okay, so we need to first look at those two sets. Okay, so we're kind of looking here now at just listing the sets from what I'm given. So P being the set of divisors of 12, so numbers that divide evenly into 12, we're looking at 1, 2, 3, 4, 6, and 12 itself. Okay, cubing the set of divisors of 9. Again, I'm looking at 1, 3, and I'm looking at 9. Okay, a bit of a shorter set there. So if I'm looking at the intersection then, the elements that are common to both of those, I have 1 and I have 3. Okay, so we can see that here, 1 and 3 are common to both of my sets. So now that we've got that sorted, okay, this set has no universal set, or this diagram will have no universal set. There's no overarching set that we're using in this question. So we can just go straight to doing our two circles. So let me see, I'm just going to turn on my to shape there to give me a hand. So I've got my two circles here. Into the intersection part, I'm going to put in the two elements that are common and putting a dot after them to show that they're elements as opposed to number of elements. So 1 and 3 are distinct elements there. Now I can fill out what is left in P, looking at my list of my elements there. Don't know why that's happening. And looking at what's left in Q, also just 9. Okay, and nice and straightforward, listing our elements there nice and easily. So then we're going to look at an exam question. Okay, so straight in with, we're going to look at an ordinary level exam question first of all, just because of the two sets. You'll find a lot of the time with the higher level, it's more the 3 set ones that we're looking at. But just to get us kind of eased into it here, 75 people said they like Chinese food. So if we want to maybe keep a note here, we could write that in here. So C is 75. That means that this whole entire circle here is supposed to be 75 people. Okay. 41 liked Indian food. So again, if I want to, I could maybe make a note of that here. And 20 like both, so that's going to go in the center. Now, if we note that 20 in the center, if I add 20 with 55, I do get the 75 that I expected there in the Chinese food circle there. The Indian, there were 41 who said they liked Indian, but there's 20 already accounted for, so that leaves me with 21 then unaccounted for. Okay, the 59 in the middle or on the outside then is going to be the people who did not like any of the foods. So how many people like Chinese food only? So we look at the Chinese food circle, but we don't include the people who liked Indian food. So I'm not including those people. So I'm just looking at this kind of blue section here, and that's 55 people. Part 2 or part C then, it says explain what the following statement means. Well, this symbol here we should recognize as cardinal number. It means the number of elements. And C dash means not C. So they're asking how many people are not in C, and the answer is 80. And in terms of this question, that means 80 people do not like Chinese food. Okay, 80 people here do not like Chinese food. Okay, so really relating that to the specific question that we're asked. So we're not saying 80 people are not in C, we're really making it specific to the question and to the survey that they're looking at. Okay, we'll look at one more question here. So we're looking at the 2016 exam question here. So Connor carries out a survey on all of the 25 students in his class. Okay, so I'm just going to pull up the calculator here so that I have it ready. Lovely. Okay, and so Connor is carrying out a survey on all of the 25 students in his class. So let's take note of that. There's 25 students in the overall set. He asks each student if they own a pet and if they own a bicycle. 6 students own neither a pet nor a bicycle. So they don't own either a pet or a bicycle, so they're going on the outside. Okay, this time 6 is not an element, 6 is a cardinal number. It's a number of elements. So it's 6 people, so the 6 people go on the outside, okay? 28% of students own both a pet and a bicycle. So that part there is going to be going into our intersection. But firstly, we have to work out what that value is. And the last point here is the ratio is 2:1. So the ratio here, this part is going to be P only, and this part is going to be Q only. So what it's telling us is there are twice as many people in P only as there are in Q only. So we have to kind of work out how much is left first of all, and different things like that. Okay, so we're going to kind of go with this one and figure out what's happening here. So there are 25 students overall. If we work out firstly what's in the middle, I'm going to get 28% of that. So if we're using our calculator there, we could use our percentage button for that one. So 28, and our percentage button is, let me see, where is my percentage button? My percentage button is here. Okay, and 25 multiplied by 28% gives me 7. So 7 people. 28% of it is 7 people. So 7 people are going to be in the intersection in the middle part. Okay, we know now the ratio of P only to Q only is 2:1. So let's work out how many people are left. So there were 25, but there's 6 on the outside, and there's 7 people who we already know are accounted for in the middle. So taking those away, it leaves me with 12 people. So I have 12 people to distribute. If it has to be a 2:1 ratio, that means I'm going to have 3 parts overall. So 2/3 parts here and 1/3 parts here. If I divide my 12 into 3 parts, that's going to be 4 people. Okay, so the 2/3 parts, that's going to be 8 people, and the 1 part here is going to be the 4 people. So 8 people are going to have or own a pet, I should say, and 4 people then own a bicycle. Okay, so slight difficulty there, I suppose, or something challenging or something just different there with the ratio. So making sure there we're looking to divide it into 3 parts altogether. So 3 different, or we need 3 parts total. So then looking back at the 12 there, dividing that into my 3 parts means that we get 4 as 1 part. So 1 part is 4, and the 2 parts then would be 8. So we get 8 is to 2 there. Okay, and our Venn diagram's nicely done out. We're going to kind of fly on a little bit and look at our 3 set Venn diagrams, because the 3 set Venn diagrams, I suppose, are where it gets maybe a little more tricky for some people, and maybe a little more common in terms of what we're going to be looking at. So a 3-step Venn diagram, essentially the same as a 2-step, or as a 2-set, I should say. We start with the intersection, we work our way outwards. If you look at the list of the steps I have here, there's really not much difference in terms of what we're looking at. There's an extra added step here. So yes, we still start by finding the intersection, but then we move to still on intersections, but just not the very middle intersection. So we look at the people who are maybe in A and B, but aren't in C. So people who are in 2 sets. So we start with the people that are in 3, And then we look at the people that are in 2 sets before lastly looking at the people that are only in 1 set. So always working our way down there, same as we did with the 2 set ones. So let's have a look then at this example here. So again, taken from an exam question. So we're given a universal set, so quite a large set here, and we're given the different sets that we have. So let's just break down the information that we have here. So I want to know, first of all, what information or what numbers, or are there any elements that are in all 3 of my sets here? So having a quick look there, I can see 6 is in all 3 of the sets, and it appears to be the only element that's in all 3. I want to look now and see what's in the intersection of P and Q, but not in OR. Okay, what's in the intersection of P and Q, but not in OR? Okay, so take away OR, so I have that the incorrect way around. So P and Q, but not in OR. So let's just see what P and Q have in common. So I'm just ignoring the 6 and just seeing what else is in common. And between P and Q, I can see that they have 8 and they have 10 in common. Yeah, they have 8 and they have 10 in common. So let's just list some of these and put them in as we go. So we have 6 in the middle with my little dot to show it's an element. I have 8 and 10 here. Let's now look at P and OR without Q. So P and OR without Q. So that's going to be 5. So that's going to be 5. So again, I can fill that in with my little dot there to show it's an element. And let's do OR and Q without P. So again, we're just looking at what's the part without the 6 there. So OR and P, or OR and Q, sorry, OR and Q, and that's going to be 2 and 12. 2 and 12. Okay, so once we have all of that information accounted for, as we have here, then it's just a matter of filling in the information that's in each set only. And we only have a few elements in that case, and then we have a few elements to go on the outside as well, 1 and 11, looking back at our universal set here to see what's been included. So lastly, we can count up the elements. So our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we have 12 elements as expected because our universal set had 12 elements altogether. Okay, so same idea, you can see there, just takes a little bit more steps, a little bit more kind of steadiness, or kind of following the same kind of steps or procedures there. So let's look through a few exam questions then, just to get again a taste of what we need to know in these sort of questions. So F is the set of factors of 12. Okay, F is the set of factors of 12. List the elements of the set F. So the factors of 12 are 1, 2, 3, 4, 6, and 12. So we should be able to list the factors fairly easily. The sets P and S are as follows. P is the set of all prime numbers. S is the set of all square numbers. So numbers that can be written as squares. Okay, numbers that can be written as something squared. The Venn diagram below shows the sets F, P, and S. F, P, and S. So they are asking us, first of all, write each of the factors of 12 from part A into the correct region in the set F in the Venn diagram. Okay, so we start off by looking to see, are there any numbers there that are factors of 12, that are prime numbers, and that are also square numbers? Well, what I would say is essentially by kind of definition, I suppose we're not really expecting much of a kind of overall intersection, but let's just break it down. Let's have a look at seeing which kind of category each of these factors falls into. So let's focus on the ones that are factors and prime. The ones that are factors and prime numbers. Okay, so let's look at the factors that are prime numbers. So that is going to be 1, and that is going, or sorry, not 1, 2, not 1, making a mistake myself there. So the first prime number is 2 and the next one is 3. Let's look at the factors of 12 then that are square numbers. So the factors of 12 that are square numbers are 1 and 4, because 1 is 1 squared and 4 is 2 squared. Okay, now none of those are overlapping there. There's nothing that's in common between those, so there's no overall intersection. Then in terms of any factors of 12 that do not fall into either of those, so the ones that would be an F only, those would be 6 and 12. So we can fill those elements in then correctly into our diagram. So 2 and 3 are prime numbers, 1 and 4 are square numbers, and 6 and 12 are just factors of 12. So they're really pushing you there to have that little bit of understanding of, you can even see kind of not just your sets, but also prime numbers, square numbers, types of numbers. And it's common enough that they would test that knowledge within your sets there, particularly the types of numbers and the different number sets. So it's just pulling all that together, and particularly things like that that maybe you haven't done in a little bit of time, just kind of revising over those and making sure that we're keeping all those straight in our heads. So let's look at these three sets here, this 2015 question. So we're given sets A, B, and C. We have to complete the Venn diagram below. So again, we're going to start in the middle. So we look to see, is there anything that all three sets have in common? And looking there, I can see that there's a 5 in all three sets. And I think that is it. So let's just fill in 5 there. If we come across any more, we can fill them in. Let's look at what A and B have in common. So I can see 2 and 3 there, and no more. So let's do 2 and 3 here. Okay, let's look then at what A and C have in common. And A and C, I can see, will have 1 in common. So let's fill that in. And lastly, let's look at B and C, and they have 4 in common. And you can see how I'm marking these off as I go to keep things clear for myself, so that when I'm looking back, I can see very clearly now what has to go into the A only, the B only, the C only sections of my diagram. So it saves me a little bit of work then in the end up. Listing the elements of each of the following sets, A union B, I'm looking for all of these two circles. So I look at the circle A and I look at the circle B, and I'm taking everything involved in those. So that if I'm listing those elements, I use my curly brackets there, and I can list them in any order at all, really. I'm going to try and list them in as best of a numerical order as I can. So I think it's just the numbers from 1 to the numbers from 1 to 9, essentially. 1, 2, 3, 4, 5, 6, 7, 8, 9. The next one is A without C. So A without C. So looking at A without C here, we're looking at the circle A, but we're taking away the part that overlaps with the circle C. So we're only going to be looking at this information here, and that's going to be 2, 3, 6, and 7. Lastly now, we want A union B intersection C. So what we're doing is we're taking all of the circle A, and we're putting that together with the intersection of B and C. So we're tying in this 4 here as well. So bringing that all together, it's 2, 3, 4, 5, sorry, 1 to start there as well. I'll just keep them in order. 3, 4, 5, 6, and 7. Okay, they say now complete the following identity. A union B intersection C is going to be the same as A union B intersection what? Okay, A union B intersection C is equal to A union B intersection, and actually what happens here is it's kind of similar to nearly our multiplication that we do. So we do the union of this one, intersection the union of this one, A union C. And we can try and break that down for ourselves here and look at what A union B would be. So A union B is all of those top 2 circles there, as we had at the start. A union B is the same as those top 2 circles. I know that what's in A and C is 2, 3, 6, and 7. Okay, I'm looking to see kind of what information is going to be lost if I'm uniting these different kind of intersections and these different things together. So the ones that I'm kind of leaving out are the C only, essentially, the C only and the B only. Okay, so A union B and where that intersects with A union C is going to leave me with just the things that are here. Okay, so it leaves me with all of A and just the things that are here, because I'm looking at where does all of those 2 circles of A and C intersect with those 2 circles of A and B. And we can see the only real overlap is obviously all of A and then the 4 from B and C. Okay, so again, we can see with these set ones, it's a lot of just kind of making you think about what you're looking at. And that's an example of our distributive rule. So union is distributive over the intersection. So an important one for us to just kind of have a little think about, I suppose. Right, let's keep going. So we're going to look at a 2014 question. So we might as well just kind of do out all of them for ourselves. So 2014, we're given the three sets, complete the Venn diagram, same as before. We're going to look and see what's in common with all three. So I can see there immediately 4 is common to all three of them. So that's going to go in the center. Looking at A and B then, I have 2 and I have 6. So let's fill that in. 2 and 6. Looking at A and C, I can see, is there anything else with A and C? There is not. So if I do B and C, then I have 8. So B and C have 8 in common. So filling in now what's left in the A only, in B only, and in C only. So A intersection B is going to be this whole section here. So that would be 2, 4, and 6. Making sure to include the 4 there. Yes, even though it's in the middle, it is still considered to be in the intersection of A and B there. Looking now at the next part. So the next part says B, take away A intersection C. So I go to my circle B and I'm going to take away the intersection of A and C. So that's this intersection here. So I don't want that part, but I am including the 2 and the 6. Okay, I am including the 2 and the 6. So B, take away A intersection C. And my apologies as well, I'm taking away this part of the question. So I'm actually taking away the 4. So I will be including the 8 there as well. So that's going to give me 2, 6, 8, and 10. The last part then, B take away A, union B take away C. So let's look at that one. So B take away A is going to be 10 and 8. And I'm uniting that with B take away C. And B take away C is going to be, would be 10, 2, and 6. So doing the union of those two kind of separate sets gives me 2, 6, 8, and 10. Okay, so we kind of are seeing there another example of some sort of distributive operation there. To write down a null set is an empty set, and that's going to be this set here, and that is the set where A intersects with C, but without B, when we take away B. So there are no elements, so it's a null set or an empty set. Okay, nearly there. We're going to look at one more question. Again, it's all just practice, and all of this just takes practice and setting these up. And you can see yourself that a lot of the times laying out the diagram isn't the hard part. Maybe it's answering some of the questions, or there's maybe just a trick to labeling the diagram the way that they want it labeled, and small little things like that. So P is the set of prime numbers less than 12, E is the set of even numbers less than 12, O is the set of odd numbers less than 12. Represent these sets on the Venn diagram. So we need to list these out firstly. So P being the set of prime numbers less than 12 is 2, 3, 5, 7, and 11. E, the set of even numbers, is 2, 4, 6, 8, and 10. And O being the set of odd numbers is going to be 1, 3, 5, 7, 9, 11. Okay, and obviously our union there is the entire set of numbers from 1 to 12. So again, looking to see what's in common there throughout all three, we can see there's no number that is prime, even, and odd. So obviously, I suppose the real issue coming in there with you can't have a number that's both even and odd. We can have intersection between prime and even. So we have 2 there between our prime and our even numbers. It's the only one. So we can put that in. Looking between even and odd there, we're not expecting any intersection there either. Okay, we're not really expecting any other intersection. Looking between prime and odd, then I have 3, 5, 7, and 11 all in that intersection. So let's just zoom in a bit to give ourselves more space. So 3, 5, 7, and 11. Anything left in prime only, there's actually not. Anything left in even only, 4, 6, 8, and 10. And anything left in odd only, it's just 1 and 9. Okay, the only number that's left then, if I count them all up, I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The only number that's actually left is 12 on the outside. Name any diagram that is a null set. Well, we actually have two null sets here. Okay, or three null sets. One of them is in the very center here. That would be A intersection B, or sorry, not A. We better use the letters in the question. So P intersection E intersection O is one example of a null set. If we want to do a different example, we could look at this one here, or even just look at the bigger set here. So that would be E intersection A, or E intersection O is another example of a null set, because there can't be a number that's both even and odd. We also have the set P only. The set P only here is the set P take away E union O. Okay, P take away E union O. We have P intersection E intersection O. We have E intersection O. And we also have this smaller set here, which is E intersection O, yes, but taking away P. Okay, so we have four different options you could answer for that. You only had to give one answer. So the main thing with all the sets there, 2 and 3 diagrams, just to follow those steps. Start from the inside, start from the middle, lay out the sets. A lot of the times it's writing out the sets beforehand, so writing out the sets, then looking to see what's in common with all of them, and then using that then to fill out your diagrams as accurately as you can, making sure that you're not kind of overlapping things, and making sure that you're comfortable picking different regions in your diagram as well, because honestly that is kind of half the thing of answering some of these later questions. But just make sure you're working through the questions there and really giving those a go at kind of filling them out as best you can into those appropriate kind of regions.